Hey everyone, so today I'm going to be showing you how you can auto-generate racks using your warehouse data in FlexSim. And I'll start by just going through some of the default rack types that are found in FlexSim. So if you go to the left side here in your library pane, under warehousing, you'll see there's a rack object. And if you click on that, you'll see there are 4 different rack types pre-built in FlexSim. That's your standard, gravity flow, pushback, and drive-in racks. And I'll start with the 3 shown here, the standard, pushback, and drive-in. And I'll show you how those rack types function in FlexSim. So I've built this model here with a source, and I am creating our full palettes and assigning a type label 1 through 3 to designate which of the 3 racks the palettes will be going into. I've connected that to our queue here, and then I'm using this send to port by expression, where I'm using that item.type to determine which rack that pallet will be sent to. And then I've also connected our fork truck here, so he'll be doing the transport of those pallets. So let me just run this model, and we'll see some examples. So you see this is our standard rack type here on the left. And in this type of rack configuration, we just have static locations. For each pallet, there will be 1 per position in the standard rack. And that's what we typically associate with a rack. However, we have 2 other types over here as well. This first one in the middle is called a pushback. And the way that that works is we'll be loading pallets from the front here. And as we add new pallets into a position, we'll be pushing those pallets backwards in the rack location. And in this setup, this is typically used for when we want to utilize a last in, first out sequencing, in which case the last pallet that's been placed in that position is the first one that gets pulled out when fulfilling orders. And then the last rack type we're showing here is called a drive-in. It's called a drive-in because you'll see the fork truck can actually drive into those aisles to place pallets. And again, these are static locations. And in this configuration, we typically are fulfilling from the opposite end. So we're actually pulling pallets out from the back. And this allows us to utilize a first in, first out sequence. Now you can imagine if we pull a pallet out that we might need to reshuffle to bring pallets forward in order to maximize space utilization. But in contrast, this is a pretty high density storage solution. So those are our common pallet racks. These can also be used to store cartons or eaches. And then I'm showing here our 4th rack type, which is called gravity flow. In this case, it's typically used for cartons, and you'll see our replenisher is actually loading the cases from the back onto these rollers where will allow gravity to flow the cases to the front. And then the order fulfillment is typically done from the opposite end, where again, we can use this first in, first out to grab these cases from the rack. So those are our rack types. If you go into the model tree, you can click on a rack and show all of the variables. And each of these can be modified in FlexScript. And I'll show some examples where I'm modifying some of these variables here in the code. But first, let me show you some example data. So this might be data that is stored in your WMS, where it shows the slot designation, the aisle, bay, and level. Maybe it shows the start level value, the increment that's changed as you move up in levels. Of course, you'll want the coordinates of your rack, the facing direction of it, maybe the slot dimensions, maybe some indicators or labels associated with that rack. Here we have whether it's a hazmat, whether it's a forward pick location, meaning this is a location that is pickable versus our reserve, which is used to replenish a forward location. Then we have our slot unit, in this case pallets, and we're picking cases off the pallet. Then we might have something like our pick path sequence and maybe a zone that's associated, that rack's associated with. So this is some example data, and using that, I've written some code, which I'll link in this video. And what it does is it takes a global table of data like this to build out racks automatically. And in this example, every row is a unique slot location with an aisle, bay, and level designation in our rack data. In this example code, we're going to be building a single rack, a standard rack, for each aisle and bay. But we might have multiple levels to each rack location, and that'll be determined by the level designation in the data. So in this case, we're going to loop through each slot. We're going to grab the aisle, bay, level, what the start level is, what that level stride is, the increment that we move up when we're moving in those levels. In the first check here, we're going to check if the rack already exists. So we'll do that. If the rack does not exist, or if the rack does exist, what we want to check next is if the number of levels is less than the current one for that slot. And so we divide the level number minus the start level by the level stride. And if we find out that it is less than, we're going to set the property number of levels equal to the level number divided by the level stride. And that'll set it to the current level based off the slot data. If the rack does not exist, we want to create an instance of it, which we can do by pulling that standard rack object from the library and adding it to the model. We'll set the location. In this case, the model is set up in feet, but the data is in inches. So we make that change. We'll set up number of bays. Number of levels by default will set as 2, and that's just because in FlexSim, if we only show one level, you actually can't see the rack. This is what one level looks like. But with 2, we have another level set here. You can actually visually see the rack. We'll set bay size, level size, slot size based off of our data, as well as using the facing direction to set the rotation on the object. And I've included in here some additional properties that you can set for that rack. And some examples might be like slot padding, which determines where an object is located within the slot when it's stored in that location. All right, so with that data, we can go to a script here. And since I've built this as a function, build racks, I can reference the global table that I'd like to build from. If I click the play button here, now we have all of those racks built automatically using our code. And so you can see each one of these locations is our aisle and bay number. And it'll have number of levels that's found in that data. It also has, of course, the correct coordinates and the facing direction, which is shown here in orange. So that's how you can auto-generate racks using FlexScripts. I hope you found this helpful. Thanks for your time.